Hey there, welcome to NASA Launchpad. I'm your host, Amber Whalen. Ever wish your teacher could just get out of town for a week? I know I did. Well, you know, there are all kinds of workshops and conferences and things that you can suggest to them. But what about one that can really help them understand more about what scientists do day to day? Well, here's one for you to mention, The History of Winter in Lake Placid, New York. And guess what? It's sponsored by NASA. Here's Peggy Mayer, Aerospace Education Specialist, telling us more about History of Winter, or how.
History of Winter project is a workshop and follow-up activities that are web-based that really intends to introduce teachers to the science behind the study of snow and ice, and to do it as scientists rather than as teachers, so that they have a chance to do some authentic science and to share that with their students, not just in the study of snow and ice, but in kind of every aspect of what they're teaching. I hope they get a chance to maybe step away from being a teacher for a little while and to be a scientist instead.
Scientist. You know, in a lot of cases, your teachers don't get to spend a whole lot of time being scientists. They go right from being told what to do in their labs in college to telling you what to do in your labs. Not a lot of time in between for their own research. But at HOW, participants get to do all kinds of research, like measuring densities of snow in snow pits, bubble layers in ice, diagramming snowflakes, even finding out about the science behind ice climbing. But hold on. Why does NASA care about all this snow and ice? Well, it turns out that the snow and ice are part of something scientists call the cryosphere. The term cryosphere describes all the parts of Earth where water is found in solid form. That includes sea ice, river ice, snow glaciers, and ice sheets. Even the frozen ground and permafrost areas are part of the cryosphere. And the cryosphere is an important part of Earth's global climate system. Here's Peggy again to explain.
Well, NASA does a lot of Earth science, and Goddard Space Flight Center, where I work, actually has more Earth scientists than any place in the world, all in one spot. So we have the Earth observing missions, including missions that study snow and ice. We have a satellite called ICESat that just studies snow and ice, and we have instruments on other satellites that study ice along with snow cover and that sort of thing, along with other kinds of terrain. So NASA is very interested in all aspects of the Earth. NASA is not just about manned spaceflight. We have a lot of other science going on.
And why is it important to NASA to include teachers? Here's Dr. Peter Wasilewski, one of the founders of HOW.
The future of the NASA workforce depends on, very clever, innovative kids growing up into first-class scientists. And I think that there's a lot of people in the NASA organization, all the way up and down the structure, that look on, and there's very strong emphasis on STEM education.
Wonder what Peter means when he talks about STEM? In this context, STEM identifies science, technology, engineering, and mathematics. And not just these topics standing alone. It really looks at how science, technology, engineering, and mathematics relate to each other and are connected to solve problems. With all the high-tech exploration NASA does, it's no wonder they want students with best ideas and a great STEM background to come to work at NASA. The teachers at HOW are trained to think and act like scientists, and then they return to their classrooms to teach their students to do the same. These teachers and students help NASA and others look more carefully at snow and log their observations. Teachers, students, and citizen scientists all help gather sets of global data that help scientists learn about the dynamics of our atmosphere and help them predict climate changes. Unique patterns of snowflakes can actually help meteorologists track a storm's movement. But studying snow? That's all well and good. At least if you live in an area that gets snow regularly. What if you're down in Florida or New Orleans or Arizona or somewhere that's not frigid in the winter? What do you care about all the snow and ice?
We practice the history of winter in Lake Placid, New York, but the same principles can be applied to anywhere. And it doesn't really matter, the basic concepts, the basic tools, the basic attitude, geologic history, history of winter, same basic principles. All we're doing is using different tools but asking the same basic questions. Now, these same basic ideas and the same attitudes can be applied to spring, fall, summer, just a different approach. Even if you're not a scientist, ultimately, it makes you a better discerning citizen. We need a lot more of those.
Okay, I get it. Scientific studies help us think critically, and practicing scientific procedures helps us to apply what we know in new situations. What we learn about ice here on Earth could be applied in ice on say Mars or Enceladus. And hey, even though experts say that the amount of new technical information is now doubling every 2 years, those scientific skills aren't. So remember, that's the history of winter. Mention it to your teachers. It might get them out of the classroom for a week and help them become better teachers and help make you a better student. So it's a win-win for everybody. Oh, and if you don't like your teacher, hey, it gets really cold up there. Just saying. Well, that's it for now. Thanks for watching. I'm Amber Whalen, and we'll catch you next time on NASA Launchpad.